So looking at worksheet 1, we are basically just analyzing the graphs. So obviously if you look here, we have a position versus time graph. So this is exactly like the graph that we got when we did our constant motion lab or the car lab. The only difference here is we have two different things, and we're graphing their motion as item A and item B, right? So we can see that A kind of runs like this and B runs like this, and we can see at 5 seconds they're at the same position at the same time. So the first thing it says is, do the cyclists start at the same point, and how do you know? If not, which is ahead? So if we look, we know that position starts down here at 0 and it increases. We don't know, we don't have any numbers, but we can easily see that it's increasing. So if this one started at 0 and this one started somewhere above, we know that it did not start at the same position. So how do we know? Well, we looked at the graph and we could see that one starts at 0 and one starts above 0 somewhere. So here we have, it says at time equals 7 seconds, which cyclist is ahead. Now we don't have an exact marking for 7 seconds, but we know it's somewhere past 5 seconds. So if we go somewhere in here, we can look and see which cyclist is ahead. So when you talk about a race and who's ahead, you're looking at a position or a place based on where you started, right? So if this person here has a position that's higher than B, that means they're ahead, right, in the race. So the next one, which, I don't know if y'all can see these, let's see. Make sure I get a little so you can see more of the page. Which cyclist is traveling faster at time equals 3 seconds? So again, this is just like the other one. We don't really have a 3-second mark, but we do know that 3 seconds comes a little bit before 5 seconds. So at the 3-second mark, which one's moving faster? Now we know that our velocity is based on the slope. Remember for the cars that we said that how fast the cars were going was our slope, which is our velocity, which is the change of position over time. So if we look at the slopes here, we don't have to calculate. We really don't have a way to calculate since we don't have numbers, but we can kind of look at how the slope is. So we see here this slope is a little bit flatter, so it's not going to be quite as fast. But if we look at this one, we definitely have a steeper slope. So we know that one's moving faster, right? So at this point at 3 seconds, this one has a slope like this one has a slope that's a little bit slower. So we can look and say for sure that A is moving at a faster rate. It says, are their velocities equal at any time? So the velocity is the slope, and even though they're at the same position at the same time here, they don't have the same slope even at that point, right? So no, their velocities are not equal because they never have the same exact slope, even though they're in the same position at that same one moment of time. And then it says, what's happening at the intersection of lines A and B? Now, I know a lot of times people think that at the intersection, that means they're running into each other, but let's think about this. If two people were running, and that's what we're looking at, I don't know if that's what it is, but that works for this scenario, and ran into each other, would the line continue after that? Would they be able to keep going? Not likely. They'd run into each other and stop, right? So since these lines keep going, we know that they didn't actually run into each other. They just were in the same position at the same time. So let's think about that. If we're running a race and we have the start line back here, I don't know if y'all can see that very well, then say this is and we're just, one of us is starting back here, and one of them had a little bit of a little later start, right? They were able to start at a higher position looking here. Then this person's running here, this person's running here, and maybe right here at this second, they're at the same position at the same time, right? It took them 5 seconds to get here. It took them 5 seconds to get here. So while they're not running into each other, they just happen to be in that same position from the start line at the same time. Let's flip to the next page and look. So the next page. Now at this point, we're looking at two different graphs. So this is the previous graph that you had on the front page, and this is our new graph. And we can see right away there's a huge difference because in this one, both of them were going in a positive direction. In this one, we now have a negative direction. And so what's happening is while their time is increasing, their position's going from a higher position and coming back closer to that 0, right? So they're moving in a negative direction. So it says here, how does the motion of cyclist A in the new graph compare to that of A in the previous graph? So if I look at A was moving in a positive direction, moving away from the origin, from 0, and now it's moving towards the origin in a negative direction. How does the motion of cyclist B compare? It looks pretty much the same, right? Same kind of flat slope. Which cyclist has the greater speed? Well, this is still going to be based on slope. So it doesn't matter if it's positive or negative. The basic slope is still going to be greater for A than it is for B, right? It's steeper. Describe what's happening at the intersections of line A and B. Just like on the last page, at A and B, they're at the same place, like the same position at the same time, but they're not running into each other. They just happen to be at that same motion from where they started. Which cyclist traveled a greater distance during the first 5 seconds? So this is easy. So it's 5 seconds right here. They're intersecting, right? I can use a little ruler here. I can draw a line over to the side just to look. And if I do it like that, okay. So B only moved from here to here, right? But A moved from here to there. So obviously cyclist A has gone a greater distance or covered more position during that 5 seconds time than B has. The next step is getting into significant figures, which I think that we've covered that, and you're probably working pretty confidently on that, so I'm not going to review that, but it will be posted in the answer key. Let's flip onto the back. So it says we're going to sketch some position time graphs. So the first one says an object is at rest. So let's think about this. If something is standing still, it's at rest, then time is changing, but the position is not changing. So it doesn't matter where we put it, which position they're at, they're just stopped, right? So this is going to be like that y equals b. There's no relationship type thing. We're going to be stopped here at a position, and time is going to pass, but we're not going to move, right? So we just have a straight line. And it doesn't matter where you put that straight line, because it didn't give us a number. It just said an object is at rest. It didn't say where it's at rest. For this one, it says an object is moving in the positive direction with a constant speed. Now we know a positive direction means you were moving away from the 0, away from the origin, right? And we know on the graphs it would be up. So with a constant speed, constant tells us that we're looking at a straight line. So I could go in, and it doesn't really matter where I do this, but I could do just a nice straight line. We've got moving positive, and it's constant. And then the last one, we have an object, sorry, let's let the camera focus for a second, there we go. An object moving away from a starting position with a constant speed and then returning to the starting position. So it doesn't matter where they start as long as they come back to it, right? So they're running somewhere and running back. So I'm going to start at position 0 just because that's easy. And say I'm going to pick, maybe we'll go up to here, and then back to there. So we started at 0, we went up in a positive direction, moving away from 0, and then came back. Now on the final page, it says to manually calculate the slope of the graphs below. So it's giving you, you have the numbers here. Remember, we don't pick points off of the data table. We pick points that are actually on the best fit line. We'll let this focus for a second. I'm not going to walk through how to calculate slope because we've already covered that extensively, but I will go ahead and do a reminder here that slope is calculated using the formula. Slope, or m, is equal to y2 minus y1 over x2 minus x1. Thank you so much. I hope you have a great day, and if you have any questions, make sure to email. Thanks. Bye.